Hello, Math 7, 8, Accelerated Math 7, 8 students. We are beginning Module 9, Lesson 8's video, which I believe, I'm confusing myself so much, but I believe it's video 19, and it is called Graphing Solutions to Inequalities. So I'm going to turn to page 43 in my book, and we are going to begin. So, graphing solutions to inequalities. The goal for today we will learn how to graph inequalities. The question that I want you to be thinking about is, what does a closed circle on a graph of an inequality mean? Basically, the thing that I want you to know about graphing inequalities is there's some specific rules, and we're calling them the in and outs. So graphing ins and outs of inequalities. To graph an inequality, you must use a number line and arrows with a circle at the end. Now, what I'm talking about with that is, here's a number line. You guys should all be familiar with the number lines, okay? The arrow with the circles at the end look like this, okay? So we have an arrow, and there's a circle at one end, an arrow, there's a circle at the other end, an arrow with a circle at the end, an arrow with a circle at the other end. So what we need to know about, however, with these arrows is an arrow with an open circle represents greater than or less than. So if the circle is open, then it is graphing or showing any value that is greater than a number or any value that is less than a number. So you have to keep the circle open because you're only talking about what is greater or what is less, okay? An arrow with a closed circle is representing greater than or equal to, or less than or equal to. So remember how we learned about there being a line under each of those symbols? It means that the possible answer could be the exact number that it sits on. So if you have, let's say x is 1, x is greater than or equal to 1, then you would put the closed circle on the 1 and then put the arrow that way. So the answer could be 1 or anything above it, okay? You'll understand these more when we actually do a couple of practice problems. So we have a problem that I want you to do. I did not do the answer because I want you to try it without me, but let's talk about it to make sure you get an idea of what you're supposed to be doing. So in the triad, it says 2 identical cars fit in a garage. The garage is 23 feet 6 inches wide. There must be 3 feet 6 inches on each side of each car. How wide can the cars be? So your job is to figure out the width of the cars, and they still need to be able to fit inside the garage. So one of the things that I like to do when I'm trying to figure these out is draw a picture. So we have a garage. Here's the garage right here, okay? We know that the garage is 23 feet 6 inches, okay? And what that means is from here to here, that's how wide the garage is, okay? And we want 2 cars to fit in there. So there's a garage door here, and there's a garage door here, and your job is to figure out how wide the cars can be, knowing that there must be 3 feet 6 inches on each side of the car. So let's pretend this is the car, okay? We're calling this car. We're calling this one car. Okay, and according to the story, it says that there has to be 3 feet 6 inches from here to here, 3 feet 6 inches from here to here, and I know the picture is not drawn to scale, it's just giving you an idea. And from here to here, it needs to be 3 feet 6 inches. Okay. So your job is to figure out how wide the cars can be, okay? So basically, you're trying to figure out an inequality that will represent this, okay? And your job is to figure out where to start. Well, we know that our total distance is 3 feet 6 inches, 23 feet and 6 inches. So my first inclination is, let's convert them all to inches or all to feet. Okay, figuring out which one is easier. For me, it would be easier to convert 23 feet into inches so that I just have a lot of inches. So if I have 23 feet, I know that there are 12 inches in 1 foot, right? And I know that I have 23 feet, right? right? So the question is how many inches would that be, okay? So actually, let's look at it this way to make it a little more simple so that you understand. If I have 23 feet, the question is, how many inches is that, okay? And so the question is, how did I get from 1 to 23? I multiplied by 23, so what you do to one side, you have to do to the other. So we're going to take 12 times 23, and we get 276 inches. So now I have 276 inches plus the 6 inches that are up here, right? So I have 276 plus the 6, so that's 12, 8, 2. So now I know that the whole garage right here is 282 inches, okay? Then my next step would be to figure out an equation or an inequality that would help support that. So if I was doing an inequality to help support that, this is now my total. So I have known, right, plus unknown equals or is greater than or equal to whatever that sign is, the equivalency, right, the total. Do you see what we're doing? So the known values are the total. So we have 282 inches. What else do we know? We know that there needs to be 3 of these, right? So we have 3 times, well, what is this? 3 feet is actually 36 inches plus 6 gives me 42. So 3 times 42 inches. We know that because there's 3 of them, right? What we don't know, how many cars are there? There's 2 cars, and we don't know how many inches the cars are, so we can put X inches. And then all of that is less than or equal to that total. Can it be greater than or equal to that total? If it was greater than, will it fit in the garage at all? The answer is no. So it has to be less than or equal to. So now you know how to do these types of problems. You're going to just use your BU chart like you know how to do, and then be cognizant of this sign and what it has to be. All right? So I would like you to try this, finish solving out this problem, and tell me what could the sizes of the cars be. Okay? And then once you figure out what the sizes of the cars be, then I want you to go ahead and graph what it would look like. Okay? Remember drawing your number line. Remember that if it is less than or equal to, that the circle has to be closed, and you start whatever X would be, that's where you start, and then if it's less than, then you're drawing your arrow to the left, because less than is always represented by an arrow to the left. Okay? All right, so you're going to try it out. Come to class on, what is today? Tuesday, so this is tonight's homework, so come to class on Wednesday knowing what that answer would be. Okay? That's it. That's all we're doing. We're going to do a lot of these practice problems that are just like this, so you'll get practice with it. So go back up to your question. First of all, did you learn how to graph inequalities? Yes. Okay, and then what does a closed circle on a graph of an inequality mean? Hopefully you can figure that out because it's right there for us. Okay? All right, my dears, pretty short, pretty simple, ready to go, and we will practice this on Wednesday. Okay, that's it. Thanks.